So, our big topic this week is arrays. Arrays are a special type of data structure that allows us to store multiple values connected to the same identifier. So, for example, we've been able to store things like the user's age in a variable. We declare the type, the name of the variable, and we can set it equal to an initial value. And then later on, we can set the age equal to a different value by modifying what the value of the variable is. Now, it's important to realize what's happening behind the scenes here. When we write this line of code, we're doing multiple things. First, we're telling the compiler, I want to create a section of memory. I want to reserve a section of memory big enough to hold an integer. And depending on the type of integer and the type of computer, that's going to be a different amount of memory. Then we're saying, I want to associate that block of memory with this name, age. Anywhere in this scope that I refer to age, I'm actually referring to that block of memory. And then here, we're saying, let's set that block of memory equal to this value. So down here, I am then referring back to that same block of memory and changing its value to this, to 20. Later on, if I decide to print out that block of memory, that variable, then I am going to get whatever the latest value was. When I say write line age, what the compiler is going to do is find the block of memory associated with this name, pull the value out of it, and give it to the write line function so that the write line function can print it to the console. So a lot of things happening behind the scenes with this single line of code. Now, an array works very similarly to this. Let's say that I want to store multiple ages. I still declare the type of thing that I'm going to store, but I add two square brackets after it. The square brackets tell the compiler I'm going to store an entire group of integers, not just one integer, but a whole group of integers, and I want them all to sit next to each other in memory. I want a memory block big enough to hold all of them. Just like with a single variable, we give it a name. This time I'm going to call it ages. And there are two different things we can do here that the book points out. One is we can create this block of memory and have it contain no information. It'll just reserve the space big enough to hold as many ages as we say. And we can do that by saying equals new int array and then how many ages we want. So in this case, we're creating a block of memory called ages, and we're going to set that block of memory big enough to have 5 integers, and each of those integers will be empty with the default value for that type. In the case of integers, that default value is 0. So in C#, our programming language that we're using in this course, I can do this with any data type. Let's say I want an array of strings called names. I want 10 of those. I can have this line of code tells the compiler create enough space to hold 10 strings, attach this identifier names to that memory, and initialize it to a bunch of empty strings, a bunch of empty values. Okay. Now, another way to initialize an array is to use an initializer list. So let me delete this for a second. So instead of this form, we can declare the array, give it a name, and then use the curly brace to provide a list of initial values. And then we put a semicolon at the end of that list. So the difference between these two lines, both of them are creating an array of integers. Both of them name that array ages. Both arrays have enough space for 5 integers. But with this line, the array is initialized to 5 default integers, in that case 0. Whereas in this line, we store these 5 specific integers in the array. And this again is called an initializer list because we're initializing the array to this list of items. Okay. Notice we don't have to specify the count explicitly because the compiler infers it from the size of our list here. When we want to use our array, if we just print it out directly like this, you'll see that what gets printed is not the values of the array, but the type of the array. It's an integer array. That's not very useful. And so what we usually do is refer to a specific item in the array. And the way we do that is using square brackets. So I'll just put some spaces here so you can see it better. So if I want to print out the first item in the array indexes always start with 0. So this is item 0, item 1, item 2, item 3, item 4. So if I want to print out the first item, I will say print item 0. Again, I'm just going to add a space here so you can see that a little better. And so there's my 0 item. And if I say I want to print item 3, it's going to be 0, 1, 2, 3. And it will refer to the value 10. And the last item is item 4 in this case, because there are 5 items starting with 0. This is the most common mistake new programmers make with arrays, forgetting that they start with index 0. Now, if I try to print item 5 here, there is no item 5 because, again, we start with 0, 1, 2, 3, 4. So if I do that, it will be an error, and it will give me an exception, index out of range. And it will tell me the index I tried to use was outside the bounds of the array. It's too high of a number. So you have to be very careful with that. Another common thing to do with arrays is to use loops with arrays. And there are a bunch of different ways to do this. I'm going to show you 2 of them. The book goes into more detail, but the most common way is to use a for loop. It works across pretty much every programming language and has worked across every programming language since the beginning of time. So the way we do this is we write for, and then we declare an index variable. Usually, as we talked about with loops, it's I. We set I equal to 0 because that is the beginning slot of the array, the initial index. We say that we want to continue as long as I is less than the number of elements we have in the array. So there are a couple ways to do this. One way is to just hard code the number of elements like this. This is not the best way, and we'll talk about why in a minute. And then we increment the index at every loop. The book uses the prefix increment operator like that. Some people prefer that style. Other people prefer this style. For for loops, it does not matter at all. And then within the block of the for loop, we can do something like, let's print whatever item we are currently looking at in the array. So let's look at this line of code. The first time we run this loop, I will be 0. So we'll print the item stored in slot 0. The next time the loop runs, I will be 1. We'll print this item, etc. We'll continue as long as I is less than 5, because that's the length of the array. So we want 0 through 4. So here we'll run this. We see all items in the array printed out in their order. Now, a better way to do this, rather than putting the exact number here, is to ask the array how big it is. Because if somebody goes and adds another item here, and then runs this code, that item won't print. Or, even worse, if they delete an item from the array, this loop will cause the program to crash, because it's expecting there to be 5 elements. So a better way to do this is, instead of putting the number here, we'll say go as long as I is less than the length of the array, whatever that length is. And this property changes as the array size changes. So we don't have to worry about keeping up with that size. So here we will print all of those items. If I change the size of the array to have fewer items, then we will still print all of the items without any issue. So again, what's happening here is we initialize our index to 0. We continue with the loop as long as our index is less than the length of the array. And we increment the index every time we run the loop. As we enter the loop body, we ask the array for the item at index I, and then we give that item to the writeLine function. Now, another way that you will commonly see array loops done is using for each syntax, which is a loop style we haven't seen yet. So for each syntax looks like this. We say for each, And then we declare a temporary variable to hold the current item that we're looking at. So in this case, I'll say int current age, then we say in, and then the name of the array. So then I can say right line, current age. So when I do this, the exact same thing happens, but this loop, what it's doing is it says for every item in this array, it's going to grab the first item, store it in this variable temporarily, just for the body of the loop, and then we can refer to that. Then when the loop goes to the next iteration, it grabs the next item, stores it in this variable, and then we can do something with it. And it repeats until we hit the very last item, and then after that, it stops. So let's step through that code really quick just so we can see how that works. So we initialize our array, and we can see down here in the variable inspector, when we have an array, we can expand it and we can see each of the values and their associated indexes. We are going to enter the loop, and we're going to take the first item. Let's collapse this so we can see it. Right now, current age is set to 0. It's initialized value, but we're going to enter the loop, and we're going to set current age equal to the first item of the array, item value 12. Print that out. Go back up here, grab the next item and store it in current age, in this case 40. You can see that change, etc. Till we get to the last item. And after that, we say, are there any more items in the array? There are not, and so we exit the loop. Now, one more thing we can do with arrays is we can change their values. So to change the value of an array is fairly easy. We just say the name of the array, the index we want to change, and what we want to change it to. Now we have to change it to something that is the same type. So we can't, for example, change this to say a string, because this is an array of integers and it won't let us do that. So we can change that to any integer we want. In fact, let's do that right before this loop and rerun this. So the array initially holds these values, and let's put a breakpoint there so we can see our array. It's got our initial values, 12, 40, 33, and 10. And after I step over this next line, we see that the item at index 0 has changed to 52, as indicated on this line. And so when we run the rest of the code, it will print out whatever the current values of the array are. Now, two more things to note about arrays. One is that we can modify the order of their contents. So when we declare the array, the order is fixed unless we change it. One way to change it is to use the array.sort function. The array sort function takes an array as its argument and sorts it in ascending order. So you can hover over this and see what it does. You can also see that there are a few different variations on this function. We're using the first variation, the first overload, that just sorts the elements in the entire one-dimensional array. This is how it sorts it. You can look that up if you're interested in the details. And there are a bunch of other ways to do custom sorting and to modify how that sorting works. But the default is usually what we want. So if I run this, now you can see when they print out, our array is now in ascending order. And I just want to show you this impact we have here. So when we start our program, we have our array in the original order that we declared it. But when we sort it, it modifies the order of the elements so that they are in ascending order. So that happens in place. This is called an in-place sort. There are other types of sorting, and other languages, when they do array sorting, they create a new array with the sorted elements. But in C#, the array.sort function does what's called an in-place sort, where it sorts the elements using the same spot of memory. All right, the other thing we might want to do is to reverse the order of the array. So array.reverse will allow us to do that. So if we run this program, we can see that now our elements are printing in the reverse order that we specified. We had 12, 40, 33, 10, but when we print them out, it's 10, 33, 40, 12. So we are going backwards. If we set a breakpoint here again, we can see that when we execute the reverse, once again, in place, our elements are rearranged so that they are now in the reverse order that we specified. We can combine these two functions like this. First sort and then reverse. And if we do that, we will get descending order from biggest to smallest. Okay. That also works with strings, which will sort alphabetically, and it will work with floats and doubles, etc. Now, the last thing we might want to do with an array is look for something that it contains. There are two ways to do this. The first way is to use a for loop. So let's put our for loop back here. And let's say we want to find the number 33. So let's create a variable here to hold the index of the element we're looking for. Call it item location. So we'll initialize it to -1 to begin with, because when we find the item, we're going to store its location. And if it's -1, we'll know that that location wasn't found, because if we say 0, that means the first location. So we'll go through every item in the array, but instead of printing it out, we will ask this question. We will say, if the item in ages spot I is equal to 33, then we want to set item location equal to our current index. Then at the end, we'll ask this question. We'll say, if item location is greater than -1, then item found at location. We have to make our string using the $sign so we can print that out. Otherwise, we'll say item was not found. So if we run this program, we'll see that it says item found at location 2. And let's step through that to see what's happening. So we create our array, it's like we said. We'll expand that so we can see it. Item location, we're going to set equal to -1 to start out with. Then we're going to enter our loop. And I is 0, so we're going to ask, does ages slot I, does the item at location 0 equal 33? Since that is false, we'll skip that and go to the next loop, item in the loop. We'll say, does the item at location 1 equal 33? Since that's not correct, we'll skip that, go to the next spot, and we'll say, does the item stored at location 2 equal 33? And again, 0, 1, 2, that is true. So we set our item location equal to whatever our current index is. In this case, it's 2. And so we see item location is now 2. And then we continue on and note that we don't find it again. And so item location remains 2. When we exit the loop, we come to this question, is item location greater than -1, meaning did we find anything? If we did, then we will print out that location and then end the program. Now, if we search for an item that we don't have, the number 8, then when we go through this program, we'll see that we never find the item. Item location stays -1, and so the answer to that question is false, and we will print item was not found. Now, there is a more efficient way to do this. Rather than continuing with the search after we found the item, we can add a statement here called break. And you can see that this highlights the for when we type that. What this does is, if we get into this code inside of this if statement, once we hit the break statement, we will exit the loop early. So we can see that happen here. Let's change our search variable to be one that we'll find. Change it to 40. And now, when we get to the second item in our array, item 1, we say, does item 1 match 40? It does. So we enter here. We set item location equal to our index, which is 1. And then we exit the loop. So that break statement jumps us out of the loop immediately, and then we proceed with the rest of the program. So that early exit strategy is something that we typically want to do. Now, usually we won't hard code a variable in like that, or a value in like this that we're searching for. We'll have a variable for it. So we'll say item to find equals, let's say we're looking for 33 again. And instead of comparing it to a number, we'll say compare it to item to find. Okay, and that will work exactly the same way. And this is handy because we can ask the user, what would you like me to search for? Convert it to an integer, and we have to convert it to an integer. If this were a string, if we say, hey, look for this item, then this will not compile and run because it can't compare a string to an integer. So we have to make sure if we do ask for user input, we use convert dot to int32, convert that to an integer first. Now, another way to do this, and this way works with every programming language that supports arrays and for loops, which is pretty much all of them, but sometimes there are faster ways to do it. You can use, for example, in C#, you can use array.binary search. In this function, you specify the array and the object you're looking for. And this code will result in the exact same output. So we're looking for the value of 33. Now, there's one caveat here to binary search. In order for binary search to work properly, the array has to be sorted. So if I run this, you'll see that it says item was not found. And the reason is, the way binary search works is it expects this array to be sorted. So if it gets to this item and says, well, that's bigger than 33, so clearly 33 is not in this list. So we have to use our array.sort first. So before you use binary search, make sure you sort the array. Once you do, it will say item found at location 2, because binary search expects this to be sorted in ascending order. So why might you use the for loop method instead of binary search is really down to this. Do you want to sort the array? Because you have to sort the array in place, if the order of the items in the array matters, you should not use binary search. You should use the for loop method instead. If the order of the items in the array does not matter, then you can sort the array and then use binary search. Sorting the array is a performance hit. So you want to structure your program so if you're doing multiple searches, you only have to sort the array one time. Doing a binary search is also a performance hit, though a much smaller one usually than sorting the array. Now, one of the reasons you may not be able to sort the array is because there may be multiple arrays in your program that the indexes have to stay in sync. For example, on your homework assignment this week. All right, that is pretty much everything I'm going to talk about with arrays this week. If you have more questions, make sure you review the text and ask on Slack or through email.